My name is Hao Cheng. Today I will be talking about the process flow diagram of the basic process of ethylene production from steam cracking of the ethane. So this, as you can see from the slides here, this is basically the most average industrial process that many industries out there are actually applying. So as you can see, it's basically splitted into two sections. So first one you can see here is the cracking process. So that's the reaction, that's the actual reaction where ethane is converted to ethene with the same carbon number, but with two less hydrogen atoms in the molecular structure. So after the cracking process, all they need to do is to separate every single impurities from the mixture and eventually attempt to actually get the most purified version of ethylene. So this is actually the big scale industrial process, but I will be talking about how we optimize it and how we apply it into our own context. So this is the reference layout that we got it from the internet. So to put it into a visualizable form, basically it started with, again, the reaction itself, where ethane is actually dehydrogenized into ethylene. It starts with a furnace, as you can see from this red diagram here. Then that's where that's what we call the pyrolysis reaction. That's where ethane is primarily cracked down into ethylene. Then this process here is basically just to adjust the conditions, and then after that you can see that there are a lot of separators here which mainly used to remove other hydrocarbons from the mixture, so that towards the end of the reaction itself you can have a high purity of ethylene, which is C2H2. And so we proposed the first process flow diagram. So the very first process flow diagram, it's very similar to the reference layout which I just shown just now. It starts with the furnace here, so but because in industrial scale, there's no way that you can get a very pure ethane feed. But the feed itself is basically natural gas, where you have a lot of other elements as well. But ethane, because we want to simplify the whole process and we don't want to take too many elements into account, so we use ethane, and also this ethane has close to about 1 to 2% of impurities, which is mainly the acid gas, hydrogen sulfide. And the first PFD itself is very similar to the reference. Same thing, the main reaction itself by the furnace, which is pyrolysis, and then followed by the whole separation process with a few columns. But we found out that once we put these into HYSYS, the software, it's getting very, very hard. So we simplified further to this second proposal. And this second proposal is pretty simple. Basically, it's we've taken out a few things, and basically we use a very simple method where ethane is primarily compressed, and then it was put into a deacidifier, which is actually a very simple splitter system. We got the acid out of the whole system, which is the H2S, because according to heuristic, this has to be removed, and impurities can poison the reaction further. Then the bottom product from here is actually a mixture which is largely comprised of ethylene itself. Then we cool it down, and we heated it up so that it becomes totally in vapor form. And then we separate it into two components, where the bottom heavy product is actually the water itself, the main moisture content, but the top product itself is the major ethylene component, where it's being cooled down. Again, this is the cooler, this is the heater, sorry for the confusion. So it's cooled down into negative 103 degrees Celsius, and that's where the ethylene turns into liquid form. It has to be in liquid form, if not we cannot separate it with the separators later on. And then it's not just a negative 103 degrees Celsius, but also 1000 kilopascal. And then we separate it with the first separator, where the top product is actually more in hydrogen, but the bottom product is the ethylene liquid. So we get the final product here, which later will be talked more about. So the amendments made are what I have said accordingly. The naphtha feed was changed to ethane because we don't want to use original naphtha feed because there are a lot of impurities to take into consideration. Then as well as instead of the furnace itself, we changed it into a conversion reactor to make things much simpler in the high-C simulation. And then instead of using 4 separators unit, we removed the whole 4 separators. We only use 2 separators to reduce a lot of side reactions, which needs to be taken into account in the simulation as well. The next topic will be on presentation B. Thank you very much.